Okay, hi everyone. Welcome to this live stream for Windows Server 2003. So I'll just share my screen. Okay, installing a VPN. Conventional dial-up access still works fine, but as you saw earlier, it can be expensive to implement, painful to manage, and vulnerable to attack. VPNs um, offer a way around these problems by providing low initial and ongoing costs, easy management, and excellent security. Windows Server 2003's routing and remote access services RRAS component includes two complete VPN implementation, one using Microsoft's point-to-point tunneling protocol PTP and one using a combination of the Internet Standard IPsec protocol and the Layer 2 tunneling protocol L2TP. The basic process of setting up a VPN is simple, but there are some things to think through before plunging ahead. Getting the VPN installation right may require small hardware or network changes plus proper configuration of the VPN service itself. We will look at this process in the following sections. Setting up your server. A VPN sits between your internal network and the internet, accepting connections from clients in the outside world. In Figure 7.8, clients 1 and 2 are using different ISPs, probably because they're at different physical locations. For example, a packet from client 1 goes from its computer to its IP to its ISP and then through some route unknown to you that eventually delivers it to the VPN server, which transforms it into a packet suitable for use on the internal network. So you can see here, Figure 7.8, VPNs provide private connections between clients and servers across the internet. So you can see here, corporate network VPN, internet ISP1, ISP2, client 1, client 2. Imagine a line around the internal network and think of it as a security boundary. In general, you'll want your VPN server to be outside any firewalls or network security measures you have in place. The most common configuration is to use two NICs, which means network interface cards. One connects to the internet and the other connects either to the private network or to an intermediate network that itself connects to the private network. Of course, you can use any type of internet connection you wish for the VPN server, cable, modems, DSL, T1, ISDN, or whatever. The point behind giving the VPN its own network adapter is that your VPN clients need a public IP address to connect to, and you probably don't want them calling directly into your internal network. That also means that things will be easiest for your VPN clients if the IP address from your VPN server's external interface is statically assigned, so it won't be changing on them when they least expect it. Installing RRAS as a VPN server. To get from your VPN, you need two pieces, a VPN client and a VPN server. In Windows Server 2003's case, having a VPN means that you're very likely to be using RRAS because you've already seen how to configure RRAS as a remote access service or AS server. This section will give the bare bones explanation just as a refresher. Installing a VPN from scratch. If you don't have RRAS installed at all, you'll need to install it, activate it, and configure it as a VPN server. The easiest way to do this is with the RRAS setup wizard. You may remember that the wizard gives you a page with several radio buttons that you use to select the kind of server you want to set up. If you followed the instructions in exercise 7.1, installing installing the routing and remote access services, you actually already have a VPN server. When you install RRAS as a remote access server, the wizard automatically sets up VPN ports for you. In exercise 7.4, you will install an RRAS VPN server from scratch. So 1. Open the RRAS MMC Management Console by selecting Start Administrative Tools, Routing and Remote Access. 2. Select the server you want to configure in the left pane of the MMC. Right-click the server and choose Configure and Enable Routing and Remote Access. The RRAS Setup wizard appears. Click the Next button. 3. In the configuration page of the wizard, select the remote access dial-up or VPN radio button and then click the Next button. 4. The remote access page appears, allowing you to select a VPN and or a dial-up server. Check only the VPN checkbox because this exercise focuses on the VPN aspect of RRAS. Click the Next button. 5. The Internet Connections page appears next. This page lists all of the demand dial and permanent network interface known to RRAS. You have to choose an interface to serve as the incoming phone number for VPN connections. Pick an interface and click the Next button. 6. The IP address assignment page appears. If you want to use DHCP, either a DHCP server on your own network or the built-in address allocator, leave the automatically radio button selected. If you want to pick out an address range from a specified range of addresses button, click the Next button. If you choose to use static addressing at this point, the wizard will give you the opportunity to define one or more address ranges to be assigned to remote clients. 7. The Managing Multiple Remote Access Servers page appears. You use this page to configure your RRAS server to work with other radius-capable servers on your network. In this case, you still don't want to use radius, so leave the No. Use routing and remote access to authenticate connection. Request button selected and click the Next button. The summary page appears. Click the Finish button to start the RRAS service and prepare your server to be configured. If the RRAS service is running on the same server as a DHCP server, you'll see a message indicating that you need to configure the DHCP relay agent. Once you've completed this exercise, you'll have a complete, ready-to-go VPN server that will start accepting connections immediately. However, you may want to configure the available ports to meet your VPN needs. That's covered in the section Configuring VPN ports below. Enabling RRAS as a VPN. If you're already using RRAS for IP routing or remote access, you can enable it as a VPN server without reinstalling. Of course, if you want to start from scratch, you can always right-click the server and use the Disable Routing and Remote Access command to wipe out the server's configuration. Recall that the General tab of the Server Properties dialog box contains controls that you use to specify whether your RRAS server is a router or a remote access server, or both. The first step in converting your existing RRAS server to handle VPN traffic is to make sure the remote access server checkbox is marked on this tab. Making this change requires you to stop and restart the RRAS service, but that's okay because the snap-in will do it for you. Then you must configure VPN ports as shown in the following sections. Configuring a VPN. VPN configuration is extremely simple. At least for PPTP. Either a server can accept VPN calls or it can't. If it can, it will have a certain number of VPN ports, all of which are configured identically. There's very little that you have to change or tweak to get a VPN server set up, but there are a few things you can adjust as you like configuring VPN ports. The biggest opportunity to configure your VPN server is to adjust the kind of VPN ports available for clients to use. Windows Server 2003 theoretically supports 16,384 PPTP connections and 30,000 L2TP connections. Though this is most likely more than your hardware can handle. In addition, you can enable or disable either PPTP or L2TP depending on what you want your remote users to have access to. You can accomplish this through the Ports Properties dialog box. Figure 7.9, the Ports Properties dialog box. For conventional remote access servers, this dialog box appears. This dialog box shows you a long list of hardware ports, but for servers that support VPN connections, there are two additional selections: two WAN mini port devices, one for PPTP and one for L2TP. These aren't really devices, they're actually virtual ports maintained by RRAS for accepting VPN connections. You can configure these ports by clicking the Configure button, which displays the Configure Device dialog box. So figure 7.10, the Configure Device dialog box. There are three controls pertinent to a VPN configuration. The remote access connections inbound only checkbox must be activated in order to accept VPN connections with this port type. To disable a VPN type, for instance, if you want to turn off L2TP, uncheck this box in the corresponding devices configure device dialog box. The demand dial routing connections inbound and outbound checkbox controls whether or not this VPN type can be used for demand dial connections. By default, this box is checked. You'll need to uncheck if you don't want to use VPN connections to link your network with other networks. The maximum ports control lets you set the number of inbound connections that this port type will support. By default, you get 5 PPTP and 5 L2TP ports when you install RRAS. You can use from 0 to 1000 ports of each by adjusting the number here. You can also use the phone number for the device field to enter the IP address of the public interface to which VPN clients connect. You might want to do this if your remote access policies accept or reject connections based on the number called by the client. Because you can assign multiple IP addresses to a single adapter, you can control VPN traffic by throttling which clients can connect to which addresses through a policy. Troubleshooting VPNs. The two primary VPN problems are the inability to establish a connection at all and the inability to reach some needed resource once connected. There's a lot of common ground between the process of troubleshooting a VPN connection and troubleshooting an ordinary remote access connection. There are some extremely simple but sometimes overlooked things to check when your VPN clients can't connect. First, make sure your client can make the underlying connection to its ISP, and then check the following things. Is RRAS installed and configured on the server? Is the server configured to allow remote access? Check the General tab of the Server Properties dialog box. Is the server configured to allow VPN traffic? Check the Ports Properties dialog box to make sure that the appropriate VPN protocol is enabled and that the number of ports with that protocol is greater than 0. Are there any available VPN ports? If you have only 10 L2TP ports allocated, the 11th caller will not be able to connect. Do the client and the server match? Is the VPN protocol used by the client enabled on the server? Windows 2000 and newer clients will try L2TP first and switch to PPTP as a second choice. However, clients on other OSs, including Windows NT, can normally expect either L2TP or PPTP. Are the network protocols for all clients enabled on the server? This is particularly good to check if you have some IPX using clients. Are the client and the server authenticated correctly? Are the username and the password correct? Does the user account in question have remote access permissions, either directly on the account or through a policy? Do the authentication settings in the server's policy, if any, match the supported set of authentication protocols? If you check all the simple stuff and find nothing wrong, it's time to move on to some slightly more sophisticated problems. These tend to affect more than one user as opposed to the simple and generally user-specific issues just outlined. The problems include the following policy problems. If you're using native mode Windows Server 2003 domain, you're using policies. These policies may have some subtle problems that show up under some circumstances. Are there any policies who allow or deny settings conflict with each other? Remember that all conditions of all policies must match to gain user access. If any condition or any policy fails, or if there are any policies that deny access, the connection will be denied. Does the user match all of the necessary conditions that are in place, such as time and date, network problems? If you're using static IP addressing, are there any addresses left in the pool? If the VPN server can't assign the address, it won't accept the connection. If you're using IPX, be sure that the client and the server settings that control whether or not the client can ask for its own node number match. If the server disallows it, the client won't be able to connect unless it already has an assigned number. Domain problems. Windows Server 2003 or AS servers can coexist with Windows NT or AS servers, and both of them can interoperate with Radius servers from Microsoft and other vendors. Sometimes, though, this interoperation doesn't work exactly as you'd expect. Some questions to ask: is the or AS servers domain membership correct? Your or AS servers don't have to be domain members unless you want to use native mode features such as remote access policies. If you're in a domain, are the server's group memberships correct? The server account must be a member of the RAS group and Internet Authentication Server Security Group. Managing your remote access server or AS server management is generally pretty easy because in most cases there's not much to manage. You set up the server and it answers calls. You will find it necessary to monitor the server's ongoing activity, and you may find it necessary to log activity for accounting or security purposes. You can monitor your server's activity in a number of ways, including having the server keep local copies of its logs and having it send logging data to a remote Radius server. In addition, you can always monitor the current status of any of the ports on your system. Microsoft's documentation distinguishes between event logging, which records significant things that happen like startup and shutdown of the RAS service, and authentication and accounting logging, which tracks things like when a user logged on and logged off. The settings for both types of logging are intermingled in the RRAS snap. And in the following sections, you'll learn about the various methods at your disposal for monitoring a VPN server. So I'm going to leave it here today for this live stream. Thanks for listening and have a nice day.